Last time we talked about this information, this data, um, as part of the exercise. But one of the things that you have to do first before you can use chi-square, for example, in this particular situation, is to convert your test score into categorical data, right? Because that will be for chi-square, you need categories. One way to automatically convert it to categorical data will be to create what we call a VLOOKUP table or the reference table. So in this particular situation, let me create a VLOOKUP table. So we will use scores here, and then this will be the interpretation column. For the moment, let's just use two interpretation. So the score 0 to 75 will be fail or 74, and all above 75 will be pass. Just use fail here. Now, so that this will be your reference table. Any score in this column that will be within the category or the range will be given an automatic interpretation. So let's use now this table to generate your VLOOKUP. So let's say, so you go to the cell where you want the result to be reported, so equals. So you go type VLOOKUP and you will automatically see the VLOOKUP pull down menu. So the first data will be the test score. This is what we will convert. And then put comma, and then we look at the table that we will use for interpretation, right? And then we will use column 2, which is pass as and fail as our interpretation. So we go to there and close the command formula, and you see 78 pass. So if you go down, fail. But of course, to really make it more to be able to apply the formula downwards, you need to make it fixed. So to fix the F264 range, we put $sign to the formula, especially for the range, so that it will tell you that it will always be that range. It will not change as you go down. Remember, when you use Excel, it goes down, and then you go down the line, you just drag it up to your number 50, and you notice we now have a pass and fail interpretation. So that's okay. Now that we have categorized our data or the scores into either pass or fail, we would like now to develop or to produce a frequency distribution of teaching method according to, or scores or interpretation of scores according to traditional method used. So this time we will use what we learned last week about pivot table. So for this, we will go to create a pivot table from the table range. So the table range will be this one, right? This will be the range that we have that will include. Okay, so now that we have selected that, okay, we will just use existing worksheet. And now you have this, and now we will select teaching method and then interpretations, right? But for the interpretation, we'll put it in the columns, and the value will also be in the column. So now you see a distribution. So we have 16 passed from the blended, failed 17 on the online, traditional 3, and pass 14 online. Oh, they all failed. That's it. Okay, it's based on our total recording. So now that we have that, this is the table we will be using for chi-square. Okay. Now, okay, we have generated our frequency distribution. What we need to do now is just copy this so that we can have two tables. The first table is the expectancy, the observed table. So let's just paste it as data. So that will be here. You have a, so let me put 0 here and 0 there. So there's no online students did not pass no, in this particular. And then let's copy this one so that we can produce the expected frequency. So we go copy and then we go here. And have here, so we have paste again the data. Now we have, so to generate the expected frequency, we need to do some manual calculations. So we will remove the expected data and then generate the the observed data and then generate the expected frequency. How do you do that? The thing is, we multiply, for example, here. So we need to multiply 20, which is the fail total, compared, and then multiply it with the total for the blended and divide it by the total number of students. So we have 6.4. We will repeat the procedure, but so then multiply by 17 here, and then divide again by this cell. Then we have 6.8. So we would assume that this will also be 6.8 because they have the same total. So, but nevertheless, it's calculated. So we have 20 multiplied by 17 and divide by this number. And then we have, as I said, it will be almost similar, 60.8. Now, to calculate for the pass expected frequency, we have to use 30 and then multiplied by, again, the 16 and then divide by 50. Okay. We will do the same for this column or cell, multiply it by 17. And I said we'll probably get the same result also for the other group, right? And that I'm sure this will also be 10.2. So we have equals, and then we have 30 multiplied by 17 over 50 and up and then close. So that will be, so we now have our expected frequency and the observed frequency, the one we actually have. Now, how do we calculate now the p or for the chi-square? So all you need to do is just here equals, and then look for the chi-square formula. That will be chi-square test. So then you see here, look for the actual range. This is the actual observed range, and then separated by comma, and then we go into the expected range, close formula, and then we have voila, our p value is 2.3876 times 0 to 9. So basically, you will not be able to make a decision